Hello everybody, welcome into another lesson. So today we are going to talk about the slope-intercept form of an equation and how you can just look at that form of the equation and identify the slope and the y-intercept. If you recall from yesterday's lesson, we have the slope-intercept form of an equation y equals mx plus b. That m is your slope. That b is your y-intercept. So it pretty much gives it away for you in the slope-intercept form. That's why that's often the most preferred form of a linear equation to work with. So let's go ahead and get started with our first example. Okay, we have y equals 2x plus 1. Well, this is in the form y equals mx plus b. That works. So, first thing we want to do is identify the slope. Well, you have a 2 coefficient on your x term, so therefore your slope is 2. Your slope would be 2. Now your b, that's your b term, which is 1, that constant is 1. So that means that 1 is your y-intercept. So your y-intercept is going to be at the point 0, 1. The y-intercept is simply where it intercepts the y-axis. Where it intercepts the y-axis, your x-coordinate's always going to be 0. And then your y-coordinate will be that value that's the constant. So that's how you find the slope in the y-intercept. And I got more. And this lesson should not be terribly long, so good news for everyone. Alright, we have y equals 3x minus 4. So we're given y equals 3x minus 4. So the coefficient on the x term is going to be 3. That means your slope is 3. Slope, pretty straightforward. Now, the constant term is negative 4. So that means your y-intercept occurs at negative 4. So the coordinate of your y-intercept will be at 0, negative 4. That would be your answer for what the y-intercept is, would be 0, negative 4. And I think you're starting to see why the best form of the equation to work with is going to be the slope-intercept form of y equals mx plus b. Because if you want, you can work with the standard form, but usually you got to try to find the y-intercept, and then you got to try to convert it to slope-intercept form to get your slope, and it's more of a pain. If you can deal with it in slope-intercept form, that is the most preferred. Alright, we have y equals 1/2 x minus 3. So y equals 1/2 x minus 3. Well, the coefficient on the x term is 1/2, therefore your slope is 1/2. So that was easy to find. Now the constant term is negative 3. That means your y-intercept occurs at negative 3. So the coordinate of your y-intercept occurs at 0, negative 3. And that would be your answer. Slope of 1/2, y-intercept at 0, negative 3. Alright, y equals 2/3 x plus 3. So y equals 2/3 x plus 3. Well, you have here the coefficient on the x term is 2/3, therefore your slope is 2/3. That'll be the answer to that. Your slope would be 2/3. Now your constant term is 3, that means your y-intercept occurs at 3. So the coordinate of your y-intercept would be at 0, 3. That would be your y-intercept would occur at 0, 3. All right. Let's see, y equals negative 1/2 x plus 6. So we have y equals negative 1/2 x plus 6. Well, the coefficient on your x term is negative 1/2, so therefore your slope is negative 1/2. Easy enough. Now your constant term is 6, so therefore your y-intercept occurs at 6. So the y-intercept will have the coordinate of 0, 6. And that would be the answer for the slope and the y-intercept. Alright, let's see. Y equals negative 1/3 x minus 2. So we have y equals negative 1/3 x minus 2. Well, the coefficient on your x term is negative 1/3, so therefore your slope would be negative 1/3. Now the constant term is negative 2, so your y-intercept will occur at negative 2. So therefore your y-intercept has a coordinate of 0, negative 2. And that's how you would find it. Alright, let's see. Y equals 8 minus 2x. So y equals 8 minus 2x. Well, this equation is not quite in slope-intercept form. However, we can convert this one to slope-intercept form. How, you ask? Well, your y is going to stay the same. It's going to be equal to, on the right-hand side, you have 8 minus 2x. You can use the commutative property of addition to make it negative 2x plus 8. That would be the exact same thing. Y would equal negative 2x plus 8. Now we have it in slope-intercept form. So the coefficient on your x term is negative 2, therefore your slope would be negative 2. And then you have the constant term as positive 8, so your y-intercept occurs at 8. Therefore the coordinate of your y-intercept is going to be 0, 8. So those are your slope and y-intercept. Alright, y equals 9 minus 3x. So we have y equals 9 minus 3x. Again, this does not start out in slope-intercept form. But on the right side, we can use the commutative property of addition to turn this into slope-intercept form. So the y equals part stays the same, but 9 minus 3x is the exact same as negative 3x plus 9. Now we have an equation in slope-intercept form. The coefficient on your x term is negative 3, therefore your slope would be negative 3. And then you have the constant term as positive 9, so your y-intercept occurs at 9, therefore the coordinate of your y-intercept would be at 0, 9. So you have a slope of negative 3 and the y-intercept occurs at 0, 9. Alright, I only got here 4 more and that's it. Alright, y equals x. We just have y equals x. Well, what is the coefficient on the x term? 1. So therefore your slope is 1. You have a slope of 1. However, you have no constant term. Other words, it's 0. This y equals x is the exact same as y equals x plus 0. If it helps you, you can insert a plus 0 to help you. So the y-intercept would occur at 0. Therefore, the coordinate of your y-intercept is at 0, 0. 0, 0 is also known as the origin because that's where the x and y axis meet. So that's another thing to keep in mind. So that one was pretty easy. 3 more. Alright, we got y equals negative x. So this time y equals negative x. Well, first, what is the coefficient on the x term? It's a negative 1, so your slope is going to be negative 1. Now, what is the constant term? It's 0. So the y-intercept occurs at 0. So the coordinate of your y-intercept is going to be 0, 0. So that one was also pretty easy too. Alright, 2 more. Y equals negative 4. Alright, so we just got y equals negative 4. So it's just y equals. Do we remember from the past couple lessons Vux Hoy? I cannot emphasize Vux Hoy enough. If you have y equals, that means a 0 slope. Y equals 0 slope. So therefore your slope is 0. There is no slope. It's just a straight horizontal line. Now your y-intercept, it gives it away. Y equals negative 4. The y-intercept occurs at negative 4, so therefore your y-intercept coordinate is 0, negative 4. Pretty easy, right? I think we'll actually do 3 more. There's a reason for this. Alright, how about y equals 5? So y equals positive 5. Well, y equals 0 slope. So automatically your slope is 0. Okay? Now, as far as the y-intercept, it gives it away. Y equals 5. So the y-intercept occurs at 5, therefore your coordinate of your y-intercept is 0, 5. Alright, 2 more, we are really done. X equals 10. So we have x equals 10. Well, just x equals. So the Vux part, x equals, means undefined slope. That's what the U stands for. So the slope is undefined. So yes, the slope is undefined. Now the y-intercept. Good question. What would be the y-intercept? Well, x means it's a vertical line. X equals undefined slope vertical line, so it's standing straight up. So x equals 10, that would have to mean this occurs at the coordinate 10, 0. Meaning that it never actually crosses the y-axis. If you have x equals, it never crosses the y-axis. So therefore, there is no y-intercept. If you have x equals, there is no y-intercept. It'll never cross the y-intercept. It'll never cross the y-axis. 1 more, and we're done. x equals negative 50. Alright, so we have x equals negative 50. So just x equals. So x equals undefined slope. So therefore the slope is undefined. Slope is undefined. Now, what would be your y-intercept? Well, if it's x equals, there is no y-intercept. So if you graph this, you'll see it's just a vertical line at the coordinate negative 50, 0. It never crosses the y-axis. So therefore, there is no y-intercept if it's just x equals. So that's been it for this lesson. Next lesson, we're going to get into how to tell if two lines are parallel or perpendicular to each other using algebraic methods. Now in geometry it's a little bit different, but in algebra there's an algebraic way to tell if they're perpendicular, parallel, or neither. So I hope everyone has a good night. Take care.